Okay, this is the next lesson. We are also using graphing calculators for, so it should be fairly quick as far as the video is concerned. We're going to be testing two means that are dependent on each other. Okay, that means that one relies on the second one. Now, if you look again, these formulas are huge. Okay, we're not going to use the formulas. We're going to use the graphing calculators because this is just too massive otherwise. Okay, so first of all, deciding whether, oh, yeah, let's look at the graphing calculator stuff. I think I moved that around. All right, so there's two different ones. We're going to do a hypothesis test and then also a confidence interval for the difference between two means. This requires a little bit more work in the graphing calculator. You'll notice you'll have to find L1 and L2, and then to find L3. This is going to be the difference between the two, because we're talking about, is there really a difference between the two means or not? You have to do the work here. So you move to the top of L3, and then you type L1 minus L2, and then we can go do the test. So this is important that you make sure that you calculate the list 3, which is the difference between the two values. And then make sure that when you're using it, use L3 for the list. Same thing with the confidence interval for the means. So moving on to example 1, can we tell the difference between something that's dependent and independent on each other? If it's independent, it's easy. You can go back and use what we did before. If it's dependent, we have to use this test. So let's look at dependent and independent. Oh, I thought I pushed play. Sorry, there we go. Okay. So here's the first example. It says classify each as independent or dependent. It says the effects of drug on reaction time measured by before and an after test. So since this is something where we're saying we're going to look at something that happens before and then something that happens after, it's definitely dependent on each other. Okay, these aren't tests that we can run separately. They have to be ran together. So this is a dependent variable, so we would use this kind of a test. So this is your practice problem. Look at this really quick. Decide if these are dependent or independent on each other. It says heights of identical twins. Now, since it really doesn't matter, since one twin is not dependent on the other, these are independent samples. So we don't have to run these tests. If you have an independent sample, you can run the test that we ran in section 9.4. Okay, example 2. Says a program for reducing the number of days missed by food handlers in a certain restaurant chain was conducted. The owner hypothesized that after the program, the workers would miss fewer days of work due to illness. Okay, so they had a bunch of workers, and they were missing days. So they ran a program, and they decided that they would see after the program if it made a difference on the number of days that workers missed. So the table shows the number of days 10 workers missed per month before and after completing the program. Is there enough evidence to support the claim that the food handlers missed fewer days after the program? So these are all dependent on each other. This is the same worker before the test and then after the test, before the test and then after the test. So these are definitely a dependent sample. So what you're going to do is you're going to put these in your graphing calculators, L1 and L2, and you're going to find the difference. And the graphing calculator will show you all this. So the hypothesis H0 is that the days missed okay, so I wrote this down from the okay, sorry, I just lost my train of thought. Let's try this again. So the hypothesis. This is not that the days missed will be greater than, we're not saying that the days missed before after will be less than the days missed before. What you're trying to say is that they're different, which means that if we take the difference of the two, that this will be greater than 0. Because if it's greater than 0, then we can definitely say that there's a difference. If it's the same as 0, then we can't say. So this will always be a one-tailed test with the mean being greater than 0. This hypothesis will always be the same. So our critical value, if we look on the t-chart, has a degrees of freedom of 9 because we have 10 data points. Critical value is 1.88. The difference between the two is 0.7. Okay, your graphing calculator will calculate that for you. Our standard deviation is 1.42. Our t-test, when we run the test, is 1.56. We cannot reject. Okay, we cannot say that this difference is definitely bigger than 0. This number would have to be bigger than 1.833. All right, practice 2. So go ahead, read the practice problem and try it. I'm not going to go over this in detail because it's, again, graphing calculator work, but let's go ahead and look at the solution. Okay, so you notice the work that's involved in all of this. Let's go back to the hypothesis a minute. Okay, so the hypothesis is basically that it's equal to 0, not equal to 0. They wanted to say if it was different, not that it was bigger than. So the value, here's your critical value to look it up on the chart. Then this stuff is all the stuff the graphing calculator will do for you. And then going through, so the test value is 1.6. We need it to be bigger than 2.015, so we cannot reject.